Today we're going to talk about an objective called Bboa. This is an acronym that we're going to use for some basic things that we deal with in algebra. So the first thing we need to talk about is, what is Bboa? Well, Bboa just stands for the building blocks of algebra. And there are four basic elements that we try to make a connection between in algebra. One of those is what we call the physical model. The physical model then can be written as an expression, or an algebraic expression. Once we have the algebraic expression, we then can create a t-chart, which is a set of coordinates that we can create a graph from, because every expression has a unique picture. So let's see if we can actually do one. So here is what I call Bboa, where we have a model, we have an expression that we're going to create from this model. We're going to then create a t-chart from this expression. We're then going to take each of these points and graph them on a coordinate grid. Now, for this particular lesson, we're going to use the key of, if you see a long, which is open, it's going to represent an X. If you see a short or just a unit square, this is going to represent a 1. If you see a closed long, that's going to represent a negative X. And a closed square will represent a negative 1. So in the model that is given in this first problem, we have 2 longs and we have 3 closed squares. Well, every model is going to be in the form of an addition problem. Okay, so addition just means put things together. So I put these things here together to build a physical model. And in this particular one, we have 2 longs, which we're going to say is 2x, because each one of the longs represents an x, and 3 closed squares, so it's plus negative 3. Now, the way things would really be written if we were to simplify this is 2x minus 3. This would be the best way and the most simplified way of writing this expression. But I like to write it as a plus problem with plus and negative to help when I'm doing my math, to help prevent careless mistakes. So now this expression is going to go in the y spot because we have this formula, y equals mx plus b. So the values of y will always be equal to, in a linear expression, mx plus b, where m refers to the slope, okay, or in this case, the 2. This equation will have a slope of 2, and the b stands for the y-intercept, which is the place in which the graph will cross the y-axis. And we'll have lessons on that a little bit later on. But what we'll do with this particular one is we now have several values of x that I want to evaluate this expression for. So we're going to multiply 2 by our first x value of negative 2. So 2 times negative 2 gives you negative 4, plus the negative 3 is going to give you a negative 7. Well, one of the things that we learned in one of our lessons, and you can do this on this particular assignment as well that we will do today, is if you understand what the b and the m represent in this t-chart, you can use those to help us. So like, for example, this b, okay, the number in this expression that represents b is negative 3. We know that this negative 3 will always be found as the y value when x is 0. Because if I were to plug a 0 into this 2x, or whatever number happens to be with the x, my answer will always be 0. And I will add a negative 3 to that. So this is negative 3. Now this number here that's associated with the x, or the m, is the slope, or it is the pattern that we are counting by as we go down our y values. So if I have a slope of 2, that means that to go from negative 3 to the next value, all I have to do is add 2, which will give me a negative 1. And then I have to add 2 again to give me a positive 1. So to go backwards, instead of adding 2, I just subtract 2. So we end up with negative 5, and then again, negative 7. So the b, the y-intercept value, is going to be the y value when x is 0. The m, or the slope, is going to determine the pattern that's counting down. In this particular one, we had a pattern of 2. So I count by 2s. If and only if my x values have a pattern of 1. And in all the ones that we have today, they will have that. Now we will take each of these coordinates and graph them on this graph. So the first coordinate we have is -2, -7, which means from the origin, we're going to go left 2, down 7, and put a dot. Then I'm going to go -1, -5, so left 1, down 5, put a dot. Right or left, none for 0, down -3. And for this activity today, all we have to do is graph minimum of 3 points. It takes 2 points to form a line, but it takes 3 points to form a pattern. So to finish out the graph, we connect the dots and we add our arrows. Let's do one more just to make sure we know what we're doing. Okay, so here is a model with 3 closed longs and 2 open squares. So the expression that is being modeled by this picture is -3x, because each of these refer to a -x, plus, because every model is a plus problem, +2. So we end up with -3x plus 2. So that's going to go in this spot right here, -3x plus 2. It goes above the y. Now we're going to do the fast way. Okay? So in the y equals mx plus b, this b number, the 2, the y-intercept, is the y value when x is 0. So I put a 2 right here. The m, or the slope, which is this -3, is going to tell us the number that we're going to count by. So that means from 2, I have to subtract 3, or add -3 to that. So you can use the number line over here to help you. I'm at 2, so if I go backwards 3, or left 3, 1, 2, 3, where am I at? I'm at -1. If I go back 3 more, 1, 2, 3, I'm now at -4. And now to go down, we subtracted 3, so to go back up, I add 3. So this one should be 5 and 8. Now since this slope is negative, that means that my graph will actually be going downhill instead of uphill. So here I've got a -2, which means left 2, up 8, which is right there. And then left 1, up 5. So 5 is right here. And then 0, 2, so that's right or left, none, up 2. So I've graphed my minimum of 3 points. So now I connect the dots and draw the arrows. And that's what I call Bboa, the building blocks of algebra, making the connection between the physical model to the expression to the t-chart to the graph.